Hi, this is Sonia Doucette. This video is meant to give you a review of some of the basics of redox chemistry that you'll need to be successful in the electrochemistry unit of this course. So I have 3 questions here that I'll answer about the reaction shown below those questions. So for the redox reaction shown below, 1. Which reactant is oxidized and which is reduced? 2. What is the oxidation state of each substance before and after the reaction occurs? And 3. What are the balanced half reactions? So the first question, which reactant is oxidized and which is reduced? So you remember that when a compound is oxidized, it loses electrons, and when a compound is reduced, it gains electrons. So I have 2 mnemonic devices to try to help you remember this. One of them is Leo, the lion, says grr. So for this one, it's lose electrons, oxidized, gain electrons, reduced. And that's the one I've always used. But there's another one that is called oil rig. And this one is oxidation is loss, reduction is gain. So you can use either of those if they help you, or none of them if you don't need them. So what is going on in this reaction in terms of which reactant is oxidized and which is reduced? So let's look at the silver cation first. The silver cation as a reactant becomes a solid silver as a product. So when this happens, the silver gains an electron. So if you're using the GER mnemonic device here, you have gain electron reduced. So the silver cation is reduced. If you look at what's going on with zinc, you have zinc solid losing 2 electrons to become the positively charged cation zinc 2 plus, which is a solute in aqueous solution. So in this case, you're losing electrons, and that means you're being oxidized, or the zinc was oxidized. So lose electrons, oxidize. So that's the Leo part of this mnemonic device. So to answer the first question, silver cation is reduced and zinc solid is oxidized. So the second part of this problem is asking what is the oxidation state of each substance before and after the reaction occurs. So finding oxidation states can be somewhat involved, and there's a whole set of rules that you remember from your previous chemistry classes, but in this case it's pretty easy. So for cations and anions that are not polyatomic, the oxidation state will simply be the charge. So the oxidation state of silver cation is +1, and the oxidation state of the zinc cation is +2. And then if you look at the solids, one of the rules to determining oxidation state is that when you have a pure solid substance without a charge, the oxidation state is going to be 0. So for both the zinc solid and the silver solid, the oxidation state will be 0. So the oxidation state, and knowing what those are, can help you figure out what's going on in terms of what is being reduced and what is being oxidized. So if you look at silver, silver goes from an oxidation state of +1 to an oxidation state of 0. So this tells you going from a positive number and down to 0 means you're gaining electrons because the charge is being reduced. Those electrons have a negative charge. And then if you look at what's going on with zinc, as a reactant, zinc has an oxidation state of 0, and as a product, zinc has an oxidation state of +2. So you go from 0 to a more positive number of +2. That means you're losing electrons because electrons have a negative charge, so your number is becoming more positive. So knowing oxidation states of the different substances involved in your redox reaction can help you answer that first question. In this case, it was easy to answer, but in some cases, you need to really think about what the oxidation state is of a substance because it's not so obvious sometimes as it was here. And then the final thing you're asked is what are the balanced half reactions? So the half reactions essentially show the reduction and the oxidation. So let's do the reduction half reaction first. And we already know that the silver cation is reduced. So what you have here is two silver cations, and you're gaining electrons, so that means electrons are going to be part of the reactants, and you're going to end up with two silvers as your product, as solid as well. So half reactions include the number of electrons either being gained or lost. So in this case, this is the complete and balanced half reaction for the reduction part of this redox equation. And then you can look at what is the oxidation half reaction. And in this case, you'll be dealing with zinc because zinc is oxidized. So you have your zinc solid, and oxidation again means that electrons are lost. So that means electrons will be part of the products. So one of your products, as you know, is the zinc cation in aqueous form, and you know that you've lost 2 electrons from that zinc solid to give you a zinc 2+ cation. So that is the balanced half reaction for the oxidation of zinc. And you can tell that you have the correct half reactions because what you should be able to do is add the two together to give you that overall redox equation again that you started with. So in order to do that, you have to cancel the electrons that appear on both sides of the equation. And in order for them to cancel out, they have to be equal to each other, and they are. So that is another indication that you have the correct half reaction. So you get rid of the 2 electrons on either side of your equation, and you're left with 2 silver cations plus the zinc solid as your reactants, going to 2 solid silvers plus zinc, 1 zinc 2+ cation in aqueous solution. So that is the same as your original redox reaction. So those are the 2 balanced half reactions for this redox reaction. So that's it. You've answered all the questions, and those are some basics that will be helpful to your success in electrochemistry in this class.